Exercise 5E, graphing log functions. Today we're learning about graphing logarithmic functions. What you need to be able to do is find the x and y intercepts of log graphs, find the vertical asymptote of a log graph, apply transformations, and be able to sketch the log function itself. So this is what the log function looks like. If you'll notice, it is actually the inverse of an exponential function, which we'll talk about in a little bit. But if we think about what an exponential function looks like, everything is the opposite. So with an exponential, you have a horizontal asymptote. With a log graph, you will have a vertical asymptote. So that will occur at x is equal to h, where h is your left and right transformation. You'll then have some sort of a log graph. Just because of my computer, it's made it super bendy, but you'll see that it approaches the asymptote and then it deviates away in that fashion. For the equation, you have some sort of a base, and then you have your left and right transformations, up and down, and you can also have a dilation factor either on the inside or the outside. So this is what I meant by it is the inverse of the exponential. So you can see that this is your exponential function. This would be your log, and this is the line y equals x there. With exponentials, our y-intercept was always at 0 and 1. That means our x-intercept now will be at 1 and 0, of course, if there's no transformations. And if we were to just pick a random point, when x is equal to 1, y will be e. Likewise with the log, when x is equal to e, y is 1. So we'll go ahead and practice now sketching. So example 14, sketch the graph of each of the following, showing any axis intercepts and the asymptote, state the domain and the range. So just a few instructions, I'm going to highlight them to make sure I don't miss anything, but we want to sketch the graph. We want to show any axis intercepts, we want to show asymptotes, and then we want to state the domain and the range for each of them as well. Okay, so let's start off with this first one. So this is just a simple log graph. It's the natural log where the base is e. We can see that what's happened is we've gone to the right by 1 and we've gone up by 3. Now, the most important point and idea is the fact that we have gone to the right by 1, which means that our asymptote is going to be at x is equal to 1. That's pretty much all the information we need. We can go ahead and sketch. So, whoops, that went a bit crazy. X, Y. Now our asymptote, as we said, is at x is equal to 1. So I'm going to put that in first and make sure we label that. And there's been no reflections or anything, so it's just going to look like our regular log graph, which will look something of that sort. Now, in terms of an asymptote or intercept rather, we do want it kind of to be a scale. So if that's 1, might want to over a little bit. Our normal log graph has its intercept at 1, but that's without a transformation. So we have moved to the right and we also have moved upwards. So we actually do need to solve for what that intercept is going to be. So to do that, I'll make y equal to 0. Take the 3 over. Now to get rid of the log, we take the base of e over. So remember that's part of our log laws. And then the 1 will come over. So I can also write it as 1 on e to the power of 3 plus 1. So that will be that intercept there. And we can clearly see that there is no y-intercept. If we did try to make x equal to 0, you'll see that you're then taking the log of a negative number, which is not defined. Next one, it's going to be a very similar idea for this one. We have moved 2 to the left, which tells us that our asymptote is now at x equals -2, and we've also gone down by 1. So we can draw our graph. And we can put in our asymptote, x equals -2. Make sure you label it. Now, for this one, usually I just go in and draw it, but we don't know if it's going to go like this through the origin or through the positive. So we should probably find the intercepts before we go ahead and draw our graph in. So I'll just start off by finding the x-intercept. So that's y equal to 0. Take the 1 over. We'll take the base e over. So x will equal to e minus 2. So if you think about e as 2.7 and then minus 2, we can see that that is going to be a positive number. So we should end up with an intercept that is here. It'll be around 0.7, so it's a very small number. We can further find the y-intercept by making x equal to 0. and that one might be a little bit harder to estimate as to whether that's a positive or a negative, but because we know we have a positive x-intercept, we can assume that it's going to be a negative y-intercept. Okay, so we can go ahead and draw our log graph in. So it should look something of this sort, and that will be our y-intercept there. And this will be e minus 2. So notice that I'm using exact values for these functions. Okay, part C. Now, the difference with this one is that we've got a negative, and a negative does mean that there's a reflection. So if my normal graph does this, a negative on the outside is a reflection in the x-axis. So just to keep that in mind as to what that's going to look like. And of course, we've got the -1, which means we move over to the right by 1. So I'll draw everything in. Okay, and it's going to look something like this. Now, because there's no other transformations, I can assume that this intercept will be at 2, because usually the x-interceptors are 1, and I've just moved it over by 1. But just to confirm, we might as well just find it. So to find the x-intercept, we'll make y equal to 0. We'll go 0 equals negative log e x minus 1. We can just divide both sides by negative, which will just give us 0 anyway. Then we can take the e over, that's e to the power of 0. E to the power of 0 is 1. Then when you take the 1 over, you'll see that it's at 2. Now, I did just realize as well that, I highlighted and I didn't even complete the question. It does ask us to state the domain and range. So I'm going to backtrack a bit. We'll do that, and then we'll continue with the domain and range for this. So the domain for this one is from the asymptote 1 not included to infinity, and the range is r, as usually is with log. So you'll notice it's like the opposite of the exponential. For this one, our asymptote is at -2 till infinity. Range is r. And for this one, our domain, we start at 1 to infinity, and the range is r. Okay, so hopefully that was easy enough. We will not forget for the next part. All right, so a few things going on here. This time we've actually got 2 reflections, so it's both in the x and the y. So if this is our normal log, this is reflection in the x, and then this would be a reflection in the y. So this is reflection in x and y. So this is the shape that we're looking at. Now remember, to figure out the true translation, we do need to pull the negative out. So we will end up with x minus 1, the opposite sign, which means I've actually moved to the right by 1. So our asymptote is at x is equal to 1. The graph has also moved up by 2. Okay, so given all this information, we can start sketching, putting in our key features, making sure we label them. All right, so once again, we don't know if it's going to do this or that or through the origin, so we need to find the intercepts before we go ahead and sketch it. So to find the x-intercept, we'll make y equal to 0. Take the log over to make it positive. Take the base, and we'll swap the x and the e squared. Okay, so e squared, e, as we said, is 2.7. So let's just go conservative and go 2, or you can think of it as 3, whatever it is. When you square it, it'll be somewhere between 4 and 9. So 1 minus a number that's between 4 and 9 will definitely be a negative number. So I can tell that my x-intercept is going to be somewhere around there. For the y-intercept, we can try as well, x equals 0. Now log e1 is just 0. So that's really nice that we actually have a proper number. So that will be 2. It'll be something like that. Okay, we can go ahead and draw in our log. Maybe I put in might just draw it, and then wherever it lands will be our intercept. And then that'll be 1 minus e squared, 0. Okay, so that's our final graph. Make sure we're labeling our axes. The domain for this one, so this time it's from -infinity till 1, not included. And our range is once again R. Okay, so for example 15, it says state the transformations of g of x equals log ex needed to form this particular graph. So we're just going from our basic graph to this graph here. So let's have a look at all the transformations. So if I have y equals 2 log e x minus 3, so we're just going from a basic graph, so we don't really need to do the dash method. Remember the order always d, r, t. So we've got a dilation of 2, there's no reflections, and then we've got 2 translations, which is the 3 and 1. So I can just list that as 1, and I can write these together. So 1, we've got a dilation of factor 2. Now, because it affects the y values, it means it's from the x-axis. And then we can say there's a translation 3 units to the right and 1 unit upwards. Okay, that's it for this lesson. See you later.